Welcome back. We've got the intrusion detection and intrusion prevention system under our belt here. Now it's time to move on to NSX Application Platform. Now, NSX Application Platform is an infrastructure component that we want to deploy, or that we need to deploy, really, in order to support malware prevention, in order to support network detection response and NSX intelligence. And what this is a set of services deployed onto a Kubernetes cluster that will support these capabilities, right? So we're using Kubernetes here because it's going to allow us to scale, to derive appropriate services in the appropriate places when we need them. And, there's a lot of stuff that we want to think about here. Now, all this is very, very well defined in the NSX documentation, but we need an NSX license. Ideally, we're going to have a Tanzu Kubernetes cluster, but we don't have to, right? If you don't have Tanzu, you're not interested in Tanzu Kubernetes or vSphere with Tanzu, and you already have an upstream Kubernetes cluster, we can support that as well. Now, my microservices platform, my Kubernetes cluster for NSX Application Platform has to have connectivity to the NSX Manager. It's also going to need connectivity out to the internet to pull down information from these varying services. I do need DNS. We're going to leverage DNS for an awful lot of stuff, especially during the setup of application platform. So I need working DNS. I need my service name and my messaging DNS name set up in DNS for that to work. We'll see that in a couple of minutes and be able to illustrate that a little further. I need time synchronization, and if I do not have internet access, if my Kubernetes environment cannot reach the internet, well, we've got some challenges to face there anyway. But I can use either, depending on what kind of access I have, I can use either the VMware registry for application platform services, or I can use a private registry if I can deploy a private Harbor registry and install that with chart support, with Helm chart support. So setting up that private registry if I need it, right? And if I need it, it's going to be, comparatively speaking, the hard way. I'm going to have to deploy Harbor and set up not only the Harbor registry to store the images, but also the chart repository to support the Helm charts. And from there, I'm also going to need to make sure that my Harbor repository, my Harbor registry, has its own CA signed certificate, right? We cannot use a self-signed certificate here. This needs to be something signed by your certificate authority. Now, as we're looking at deploying application platform, we have three different form factors that we look at, right? We've got our standard form factor and our advanced form factor. These are what we're going to use in various production environments. And then we have an evaluation form factor that maybe we're going to use in the context of, say, a lab or a proof of concept. The difference between the standard and enhanced or advanced form factor is the size of the Kubernetes worker nodes and the services that we can then deploy on those. A standard Kubernetes worker node, a standard form factor, is a worker node with 4 virtual processors and 16 gigs of RAM, and I need 3 worker nodes, right? So that's 4 processors and 16 gigs of RAM times 3 that I need for the standard form factor. The enhanced form factor requires 16 virtual processors and 64 gigs of RAM per worker node. And again, that's times 3 worker nodes. So 16 times 3 virtual processors and 64 gigs times 3 worker nodes, right? So 64 gigs of memory times 3. That's a pretty significant resource jump. Now, the evaluation mode is a single worker node with 16 virtual processors and 64 gigs of RAM. So to deploy application platform. We're not going through the whole Kubernetes cluster build here. I mean, this is something you can work with your local Kubernetes admins to kind of help them get built out. The Kubernetes requirements are pretty straightforward, right? We just talked about resources, and we've got 3 nodes that we need plus a control plane node. And it's all, like I said, it's all very, very clearly defined in the documentation. Now, once you've got that, then we have to deploy the application platform services onto that cluster. And that's what we're doing here through the NSX UI. Now, here we're under the System tab, under the Configuration header. There's a big NSX Application Platform menu on the left. And we're going to click on that. There's going to be a big button that says Start NSX Application Platform Deployment. When we click on that, we are presented with a workflow where we're going to choose our repositories by default. We're going to use these private registry.vmware.com registries, which is great if you have internet access. But this, if you don't have internet access from your Kubernetes cluster, this is what we were talking about, where we need that private Helm chart. Then we'll select the version of application platform we want to deploy and all that kind of stuff. And we'll go ahead and move forward from there. Now, in our configuration, we're going to need to upload a config file. This is in Kubernetes speak called a kubeconfig file. This is going to have information about that target cluster, credentials, or authentication tokens, things like that, ways to go ahead and get logged into that. And this is also going to be where we look for our service and messaging FQDNs. These are the 2 big pieces that we need DNS for, right? Because the deployment of application platform is going to take these values, look them up in DNS, and use the IP addresses that these resolve to configure these components in the ingress controller. And then we're going to choose our form factor, right? Standard, advanced, evaluation, whichever we're trying to deploy. Now, we're going to go from there. Once we set all this up, we're going to go through and validate a whole bunch of things. And I love all these pre-checks because I'd rather fail before than during the deployment. So we're going to go validate. And it's everything from, do we have enough resources, to do we have valid licensing for NSX, and all these different things. So it's just a bunch of checks that we want to make sure are good before we go ahead and dive into the deployment of the services. From that point, we're going to start deploying all of the Kubernetes pods onto the targeted Kubernetes cluster. And when it's all done, we should see something like this, where we have a dashboard showing overall application platform usage, our control plane node, any worker nodes that we've deployed, what form factor we're in, what version we've deployed, so on and so forth. So we get a lot of information here. Now, we can also look at the services deployed in this same UI. And looking at the services deployed gives us information about our messaging service, the configuration database service, the platform services, the metrics service. And these are all deployed in both standard and advanced versions of application platform. The advanced form factor also deploys an analytics service and a data storage service. These are both used by NSX Intelligence to bring in all the flow data and analyze it as we might use it. We'll talk about NSX Intelligence in an upcoming video. Now, here's just a different view of what we just talked about, where we're looking at these Kubernetes clusters, and we see the different pods full of services that we deploy in the advanced form factor on the top and the standard form factor on the bottom. Now, here's a quick Kubernetes primer, right? We're not getting deep. We're not getting complicated. We're not going through details of all of this, but a quick primer of things you might do in the Kubernetes cluster if you have to validate what's going on in your application platform Kubernetes cluster. Everything in Kubernetes is deployed using a namespace, right? Into a namespace. A namespace is kind of like a tenant boundary, if you will. Kube control is the command line command that gives us the API access into into Kubernetes, right? It's our API client. And so if I run the kube control command with the argument get namespaces, that reaches out to Kubernetes and gets me a list of all of the namespaces in the cluster, right? I can use the get pods command against that namespace to see the different pods that are deployed. Now, a pod is just the atomic unit that Kubernetes deploys, right? It's going to contain one or more containers running a given service or a set of services. Describe pod, right? If we look at the next command, describe pod gives me details about the containers in that pod and what they're doing, right? So get pod gives me kind of a summary. Describe pod will get me a detailed description, right? Kube control logs gets me the application logs. I can look at the application logs in a namespace or for a given container. And then I can look at get events. Now, the events are different than logs, right? The events are Kubernetes deployment or teardown events or things like that, where the logs are going to be the application logs for the services running inside the pods. So logs and events have different purposes. And we're going to use those to do things like get all of our namespaces. So here we can see what's there. And if we look at this, we've got 3 namespaces in this namespaces list highlighted in bold. The Cert Manager, the NSX Platform, and the Project Contour namespaces. These are the 3 namespaces that Application Platform creates and in turn uses. Most of the stuff we're working with is going to live in the NSX Platform namespace. If we look at the pods, if we do a get pods for the NSX Platform namespace, we see a big long list of stuff. Notice that this is cropped output. This is truncated. This is not complete. You're going to see a whole lot of stuff scroll by for your Kubernetes cluster, right? So let's go take a look at this and look at the deployment of Application Platform. Now, we don't have a live lab on this. We would prefer to have a live lab, but for reliability's sake, we want you to see the process more than we want it to be live. So here we're just doing a simulation. Now, when you launch the simulation, I want you to pay careful attention to what's said in the text that you're following along, the instructions you're following along with, because this is not a live environment. The step that you're looking at in the instructions will very, very clearly define where the hotspot is to click. So it's not something that I can just, click wherever, right? If it says open Chrome by clicking the icon on the system tray, that doesn't matter that there's an icon on the desktop, right? That icon on the desktop is not the hotspot. So you want to be careful with that. But we want to give you some exposure to what's going on. And so we have these simulations. So go ahead and run through the simulation. Come back, we'll go ahead and wrap up this lesson. All right. That wasn't quite as fun as doing it for real, but it's really valuable to be able to step through this process. You may have a Kubernetes cluster back in your lab that you can deploy this onto. And now you know how to go through that process. So what did we do? We talked about why we have Application Platform. It's ultimately to support the services we're about to talk about. And we talked about how to deploy it and make sure we have Application Platform available. Come back in the next video. We'll start talking about Application Platform focused services. Can't wait to see you there.